Good day, everyone. Once again, we're back with another discussion for statistics and probability. So, today we are going to cover Venn diagram under uncertainty and probability. So, let's get started. On this lecture, we are going to cover the topic of uncertainty, which is a very common topic in statistics and probability. So, the term probability itself is closely associated with the term uncertainty or hindi kasiguraduhan. So, let's start with defining what uncertainty is. In a real world, uncertainty, or sometimes called error or bias for statistics, is a part of everyday life. But in statistics, we try to quantify just how much uncertainty is in our experiment. So we are trying to measure how much uncertainty there is, okay? And we can do that through survey or test results. There are actually two main types of uncertainty. The first one is what you call as epistemic, which means that we don't know because there is a lack of data or experience. The other form is what we call aleatoric, which refers to things that are just simply unknown. Like, for example, when you throw a dice, you do not know what is going to be the next number. So those are the two types of uncertainty. And people can quantify uncertainty through the notion of probability or chance. And let's say we have this example that if students were asked for probability that whether they would pass the next quiz, they may tell you a number in between 0 to 100%. Factors that would contribute to their answers may be based from their previous experiences. Like, for example, there is a studious student or a learner who has passed exam many times and is very confident. They can say that they will pass 100% or 85% above, right? So those are the things that can tell you or give you an idea about the notion of probability and chance. And here at the bottom right of my screen, you can see the formula which we will be using on the succeeding discussions for uncertainty. So when considering probabilities of events, we should take note that a particular context wherein possible outcomes are well defined, you call them as random process, wherein we do not know which of the possible outcomes will occur, but we do know what is on the list of possible outcomes. We can also view the probability of an event as its long run, empirical frequency, or the fraction of times that the event may have occurred under repeated trials of the random process. So, here are some of the sources of uncertainty. You have interpolation errors, model bias, numerical errors, observational errors, and parameter uncertainty. So I won't be expounding on each source of uncertainty, but rather let's focus on an example in order for us to learn how random processes are being done. So on the left side, you can see some examples, and your choices are on the right side. So what I would like you to do is match these examples, and then I'll give you a certain time to do it. So if you're done, let's look at the answers. All right, so here for letter A, getting a head in the next toss of a two-headed coin. So of course, that outcome is certain because the coin has two heads. It does not have a tail. So whichever way it flips, the outcome is certain that you will get heads. Letter B, the outcome is impossible. That's for number 4, example number 4. Getting a 7 when you roll a dice. That's because dice only has numbers 1 to 6. It does not have 7. So the outcome is impossible. And then for letter C, the outcome has an even chance of occurring. And that goes for number 1, which is a couple having a female child or expecting a female child, because you can have a male or a female. And then finally, letter D, the outcome has a strong but not a certain chance of occurring. For the example, it's number 3, getting a sum of 8 or more after pulling 4 cards in a deck. So there's a strong chance that it could happen, but it's not guaranteed for you to get a sum of 8, right? What if you have pulled 2 aces and 2 number 2s, right? So you won't get a sum of 8. So you see, we have an idea now what are some of the random processes and some examples that we could attach to it or show. So let's go now to the concept, or what you call the Venn diagram. So the Venn diagram is an illustration that uses circles to show the relationship among things or finite groups of things. Circles that overlap have a commonality, when circles that do not overlap do not share those traits. Now, the Venn diagram helps to visualize, represent the similarities and differences between two concepts. So, the Venn diagram is a good tool or method for you to use to determine probability and uncertainty. And again, this was developed by John Venn, thus the term Venn diagram. So, for example, you have 2 circles for your Venn diagram. Let's identify A, B, where is A or B, and then where is A and B, and then finally, where is not A. So, of course, letter A is your leftmost circle. And then your letter B would be your right circle. A or B is the 2 circles except for the space in the middle, right? Because we are saying here A or B. Take note of the preposition, right? But when you say A and B, okay, now it covers both. It's not A alone, it's not B alone, but it has to be the 2. Thus, it's the circle at the middle where the 2 circles intertwine or meet. And then finally, when you say not A, it's everything outside of the 2 circles. There. It's B and all the spaces outside your letter A. So that's how you identify things in your Venn diagram. Now, for a sample problem, let's say there are a total of 30 students. And then from those 30 students, 10 people have said they like basketball. Another 10 students said that they wanted volleyball or like volleyball. And then there are 5 students who like both. They like basketball as much as they like volleyball. So how are we going to plot that example into a Venn diagram? Okay, so using that example, we have already placed numbers. So here we can see 5 likes basketball, and then there's a 5 in the middle, and then there's a 5 in the volleyball. How did that happen? First, we said that 10 people or 10 students likes basketball. So if you would add the 5 on your left circle as well as the 5 in the middle, you will get 10 students. Same goes for the 10 students who like volleyball. You would add the 5 students from your right circle and then the 5 at the center, which gives you 10. Now, 5 likes both because it means that they like the sport equally. They like basketball and volleyball. Thus, we have the number 5 at the middle. Now, the problem is that we have 30 students. So we were only able to identify 15 people using the Venn diagram. So what happens to the other 15? We can say that the 15 students do not like basketball and volleyball. Okay? Or those are what you call now as the uncertain part, or the portion of your assessment which is uncertain. Okay, so that's what we mentioned. The probability is equal to likes basketball is 10/30, and then the probability of those who likes basketball or volleyball is 15/30, and then the probability of those who likes basketball and volleyball is 5. Then finally, the probability of students that does not like basketball and volleyball is 15. I would like you to create a Venn diagram for this scenario. There are 20 students in the class, 5 students like math, represented by A, and then there are 6 students who like English, represented by B, and then 2 students like both subjects equally. Now, I would like for you to measure uncertainty and probabilities using the Venn diagram. If you would like to know the answer to this, feel free to send me a message or comment down below in this video. And that wraps up our discussion for Statistics and Probability 9. I hope you have learned something for today. And as always, feel free to follow me in all the social media platforms I am in. With that, thank you so much, and to God be all the glory. Till our next episode.